You know, it's pretty amazing when you think about it. There's this invisible force that powers literally everything in our modern world. But the electricity that's flowing through your walls right now, it has a surprisingly dramatic history. It's a story packed with brilliant minds, fierce rivalries, and a high-stakes battle that basically decided how we would build the future. So here's a question for you. Have you ever stopped to think about the power coming out of your wall outlet? It's actually fundamentally different from the power that's charging your phone's battery. And understanding that one little difference, well, that's the key to unlocking one of the greatest technological showdowns in history. To really get why this was such a big deal, we have to kind of jump in a time machine. Picture the late 19th century. We're talking about a world lit by flickering gas lamps and powered by steam engines. Electricity was this magical new thing on the horizon, but it was facing a truly massive challenge. I mean, just imagine trying to build a system from scratch to deliver this brand new, invisible energy source to millions of people. It wasn't just about inventing a light bulb. No, it was about inventing the entire network to power it. That was the real puzzle that needed to be solved. And the first person to step up with a really complete solution was a name you definitely know, Thomas Edison. His big answer to this challenge was a whole system built around something called direct current, or DC for short. So what is DC anyway? Honestly, it's beautifully simple. The electricity just flows in one steady, direct path, from the power source to the device and back again. The best way to think about it is like water flowing through a pipe, always moving in the same direction. It's simple, it's predictable, and it was easy to get your head around. And this, right here, gets to both the brilliance and the fatal flaw of Edison's system. On one hand, DC was perfect for his amazing new light bulbs. It worked great. But, and this is a huge but, DC was terrible at traveling long distances. It would lose huge amounts of power. So, to light up a whole city, you'd literally need a loud, dirty power plant on almost every single block. It just wasn't going to scale. Now, that massive weakness in Edison's plan, it opened the door wide for a challenger, someone with a completely different, almost radical idea. His name was Nikola Tesla, and his solution was a system called alternating current, or AC. Okay, so if DC is that steady, one-way river, AC is much more like the tide. The current doesn't just flow one way. It rapidly alternates its direction, basically pushing and pulling the electrons back and forth over and over. Now, it might sound a little weird and less intuitive, but this sloshing effect, it held a secret advantage that was about to change everything. And here was that secret weapon. See, with AC, you could use a simple device called a transformer to step up the voltage to incredibly high levels. And at that super high voltage, electricity could travel for hundreds of miles with almost no energy loss at all. Then, you could just use another transformer to safely step it down right before it went into someone's house. This was the absolute game changer. And just like that, the stage was set for a massive showdown. And this wasn't just some friendly debate between scientists. Oh no, this was a public, corporate, and technological battle for the future of energy. It famously became known as the War of Currents. So you really had two competing visions for the future. On one side, you had Edison with his short-range DC system that needed a power plant on every corner, and on the other, you had Tesla with his long-range AC system that could power huge areas from a single station miles away. The whole fight really came down to one thing: how far could you send the power? Now, Edison had the early lead. He opened his first power station back in 1882. But the tide really started to turn at the 1893 Chicago World's Fair. That's where Tesla and his partner George Westinghouse lit up the entire exhibition with AC power, and it just dazzled the world. The final nail in the coffin, though, came in 1896 when the Niagara Falls project used AC to power the city of Buffalo, over 20 miles away. The war was, for all intents and purposes, over. Okay, so that's all fascinating history, but what does this battle from over 100 years ago mean for us, right now? Well, the verdicts from that war is all around us. It's in every single outlet in your home. And the winner was, without a doubt, alternating current. AC's ability to travel long distances so efficiently made it the only logical choice for building out the power grids for the entire nation, and eventually the world. The electricity in your wall? That is the direct legacy of Tesla's victory. But here's the twist in the story, and this is what makes it so fascinating. While AC won the battle for the grid, it didn't win everything. In fact, almost every single modern electronic device you own, your laptop, your phone, your TV, they all actually run on DC power. So, in a strange twist of fate, Edison's current won the battle for the device itself. You know that little power brick on your laptop charger, the one that gets kind of warm? Its entire job is to be a tiny peace treaty in the war of currents. It takes the high voltage AC from your wall and converts it into the low voltage DC that your laptop actually needs to run. We ended up with this hybrid system, a truce that we all rely on every single day without even thinking about it. Which leaves us with one last really interesting question. Our energy future, we're talking solar panels, big battery storage systems, electric cars, it's all based on technology that is natively DC. So as we start moving away from these huge centralized AC power plants, are we, maybe without even realizing it, starting to reopen the case? Could the 21st century actually see the quiet return of direct current? Something to think about.